Hey, welcome! Today we're going to dive into one of the biggest and frankly coolest stories happening on our planet all the time, the journey of water. Seriously, it's this epic tale of travel and transformation, a system that connects pretty much every living thing on Earth. So let's just start with a simple question. I mean, sure, we all know it falls from the clouds, right? But how in the world does the water get up there to begin with? And how does it make the trip from, say, the middle of the Pacific Ocean all the way to the middle of a continent? Well, it turns out it's all part of this absolutely massive planet-wide recycling machine. And this isn't just about the weather you see on the news. It's a global engine fueled by the sun, and it's constantly moving water all over the place, shaping our entire world as it goes. So let's dive in and take a closer look at this incredible system. Okay, so this right here is probably the picture you've seen in science class. It's the classic water cycle. And what's so cool about it is that it's a perfect loop. There's no real start or finish. You can see all the key parts, water going up from the ocean, making clouds, raining over the land, and then eventually flowing right back to the sea. The two big forces driving this whole thing, the sun's energy, which gives the water the lift it needs, and good old gravity, which brings it all back down. And, there's a fancy name for this whole process, the hydrologic cycle. It's really just the official term for the path water takes as it moves around, changing from liquid to gas and even solid ice. On a global scale, it's a closed system, which means the water you drink today could have been in a cloud last week or in a dinosaur millions of years ago. We're always working with the same amount of water. To really get a handle on this cycle, I think it helps to break it down into two main parts. You've got the journey up into the sky and then the journey back down to Earth. And it all really boils down to these four main steps. Water gets up into the atmosphere through evaporation and transpiration, and it comes back down to us through condensation and precipitation. Let's take a quick look at each one. So the whole upward journey kicks off when liquid water gets heated up and changes state. It transforms into this invisible gas, water vapor, and starts to rise up into the air. You can't see it, but it is all around us, all the time. So where does most of this water vapor actually come from? Well, get this. A whopping 86% of all the moisture in our atmosphere starts out by evaporating from the surface of the oceans. I mean, think about that. That's a huge number, and it just shows you how important the oceans are to this whole system. So there are basically two main highways for water to get into the air. The first one is evaporation. That's when the sun heats up water in oceans or lakes, and it just turns into vapor. But then there's transpiration. This is the biological side of things. You can literally think of it as plants breathing out. They suck water up through their roots and then release it as water vapor from tiny little pores in their leaves. Okay, so now for the trip back down. As all that invisible water vapor rises higher and higher, the air gets colder. And that cooling makes the vapor change back into teeny tiny liquid water droplets. That process, it's called condensation. And when billions and billions of these little droplets get together, well, that's what a cloud is. Eventually, those little water droplets in the clouds start bumping into each other and combining. Once they get big enough and heavy enough, gravity just takes over. The cloud can't hold them up anymore and they fall back to Earth. We call this precipitation. And yeah, depending on how cold it is, it can be rain, snow, sleet, or even hail. But the story doesn't end when the rain hits the dirt. The water then has a big decision to make. Is it going to travel over the land or is it going to go under it? So once water hits the ground, it can take one of two main paths. If it flows across the land into streams and rivers, we call that surface runoff. You see this a lot when the ground is already soaked or, covered in concrete or pavement. But the other path is infiltration. This is where the ground acts like a giant sponge, and the water soaks down into the soil to become groundwater. Okay, now here is where things get really, really interesting. We usually think of forests as just using up water, right? But it turns out the science is showing us they play a much more active and honestly surprising role in the whole water cycle. It's a pretty wild question when you stop and think about it. We know they breathe out moisture, that's transpiration, but can an entire forest actually influence the weather and pull rain towards it? Now, check this out, because this slide shows a huge shift in scientific thinking. For the longest time, everyone followed that blue line, the dominant paradigm. The idea was pretty simple. More trees means they drink more water, so there's less left to the ground. Makes sense, right? But it turns out it's more complicated. Look at the new line, the revised paradigm. What researchers are finding now is that as you add more trees, their roots and the healthy soil they create act like a giant sponge. This helps way more rainwater soak deep into the ground. That's that infiltration we were talking about. So up to a point, more trees can actually mean more water stored underground. It just flips what we thought we knew on its head. And this leads to an even wilder idea called the biotic pump theory. The idea here is that huge forests don't just sit there releasing water. All of that water vapor rising from millions of trees actually creates a low pressure zone above the forest. It's almost like a giant natural vacuum cleaner. And that pressure difference can actively suck moist air from over the oceans deep into the middle of continents. It means forests aren't just part of the cycle. They might actually be one of the engines that drives it. But, and you probably knew a but was coming, this incredibly elegant, self-regulating system that has worked for millions of years is now starting to face some serious new pressures. Our activities are beginning to change the fundamental rules of the water cycle. And there's this term that scientists are using that really paints a picture: climate whiplash. It's this idea that we're seeing more and more of these rapid, extreme swings between terrible drought and massive floods, sometimes in the exact same place. So what are we doing that's causing this? Well, it really boils down to three main things. First, global warming. As the air gets warmer, it can hold more moisture, which basically supercharges storms and leads to more intense rain. Second, deforestation. When we cut down forests, we reduce that crucial transpiration and weaken that biotic pump, which can mess with rainfall patterns thousands of miles away. And third, urbanization. All our roads and buildings seal up the ground, which stops that vital infiltration and turns gentle rain into sudden and often damaging floods. This quote from Professor Albert Van Dyke just nails it. He says, these things, floods, droughts, heat waves, they aren't just random one-off weather events. They're actually symptoms of a global water cycle that is becoming less stable. So here's the bottom line. This ancient, powerful, life-giving rhythm of the hydrologic cycle is being disrupted. And that means understanding how it all works, from evaporation to the role of forest, is no longer just for a science test. It's become absolutely essential for our future. And that really leaves us with a huge question to think about. As this fundamental system of our planet continues to shift, it really challenges us to think differently about how we build our cities, how we manage our land, and ultimately how we can learn to work with this great water journey instead of against it.